So, listen everyone. So, as discussed, whenever there is a changing magnetic field, there will be some induced electric field. Okay, whenever there is a changing magnetic field, there will be some induced electric field. Suppose if a conductor is there, okay, and the magnetic field is changing with time. So, inside the conductor, if you take any small part, through that flux is going to change. So we can say that through this conductor flux is changing, so some induced EMF will be generated, and because of that induced EMF, some induced we can say current carrying small loops will be generated. Now, how the loops will be there? It will be random. Okay, we can't exactly tell how it will be there. Okay, but it will be there. Okay, and it will be in such a way that they are not going to intersect each other. It's very important point. They are not going to intersect each other. If it is a case of a symmetrical one, then we can say this will come concentric circles. But here, in any random conductor, it will come in random shape. Okay. So basically, what is eddy current? Whenever there is a change in flux through any conductor, whenever there is a change in flux through any conductor, random loops of current non-intersecting each other are formed, known as eddy currents, and loss due to it is called eddy current loss. Is this clear? Now, the eddy current has some many applications also, and some problems also. Like, see, application is basically like induction. Like, the induction cooker which you use, or induction stove. There, what happens in this induction? Basically, there used to be some coil like this. Okay, inductor, and that is used, that is basically producing some varying magnetic field. So when you keep a vessel on that, on the bottom of the vessel there used to be some metal in which eddy current loss happens, and which is only used to cook food. So induction furnace. So in industries, these are used to heat any material. Okay, metals, magnetic braking or damping. Like if you take a north pole, and like some, if you take a conductor, okay, plate, and between two magnets, and if you slightly, like if you draw, like what do you call it, slide it like this, so it will quickly damp out, or it will quickly stop. Why? There's a magnetic field. Okay, and since this conductor is moving, so flux will be changing, and there will be some loss, eddy current loss, which because of which it's going to stop quicker compared to without magnetic field, etc. So these are like some of the applications. Apart from that, this is having a problem also. Why? Because we know that all many AC instruments are there. In AC, that current is going to change the direction. So because of that changing current direction, some flux will be there, like like especially in a solenoid, or some you can say AC generator, motor, transformer. There will be some changing flux, and because of that changing flux in the conducting part, there will be some eddy current loss. So to avoid the eddy current loss, or not avoid, to reduce the eddy current loss, what we do to reduce eddy current loss, we cut conductors into small plates, thin plates, insulate them, and stack together. Okay. So we are going to cut the conductor into thin plated, insulate them and extract together. So it will become something like this, like this. Instead of taking a single conductor. So with the help of this, what is going to happen in this? The current loops will become less now. We can see now only in this small part loop can be formed. So many loops will be reduced, and this way we are going to reduce the eddy current loss.